Hi, my name is Monica Lund, and I'll be talking about the ALUM Crystal Lab. This is the first of 3 videos tracking the progress of my vial's ALUM crystal growth, and it has been about 3 days since I performed the experiment. This clear liquid in the vial contains an aqueous solution of ALUM, which my lab partner and I produced ourselves. In order to make the ALUM, we first dissolved aluminum foil in potassium hydroxide, which is a strong base. While the aluminum was able to dissolve, some impurities remained solid, which we were able to filter out. Then, we slowly mixed the aluminum filtrate with sulfuric acid, a strong acid that initially prompts for the aluminum hydroxide to precipitate. By adding more sulfuric acid, minimally heating the beaker on a hot plate, and stirring the beaker's contents, the basic aluminum hydroxide was neutralized by the strong acid and was subsequently dissolved. Upon the aluminum hydroxide's complete dissolution, we put the beaker in an ice bath, which prompted the precipitation of crystalline alum. The alum was repeatedly rinsed with an ethanol water mixture and then vacuum filtered so that as much of the strong acid could be separated from the alum as possible. In total, we were able to make 19 grams of alum crystals. We mixed 5.6 grams of the alum crystals with 40 milliliters of water to make our saturated aqueous solution. Finally, we gravity filtered 20 milliliters of this solution into each of our vials. I capped my vial and brought it home, where I secured a Kim wipe over the top with a rubber band so that the water is able to evaporate from the top. So far, there doesn't really happen to be any visible signs of crystal growth, as the vial simply contains clear liquid. Thus, more progress videos of the alum crystals will have to be shown. While this experiment was designed for alum, another possible crystal can be grown from sodium chloride. If you were to do this experiment with sodium chloride instead, you'd rather use hydrochloric acid and sodium hydroxide to create a solution that would be able to create the salt crystals. Similar to the concept of neutralization when making the alum crystals, the hydrochloric acid would serve as a strong acid to combat the sodium hydroxide, which is a strong base. The procedure for sodium chloride crystals thus would vary little from the alum crystals. While both procedures require for the water to evaporate slowly in order for the crystals to form, there are other methods for growing crystals. According to MIT's X-ray diffraction facility, an example of a different method for growing crystals is called liquid-liquid diffusion. In this procedure, solution 1, which has a higher density than solution 2, is poured into a receptacle, where solution 2 is carefully layered on top of it so that the solutions do not immediately mix. This can happen by skillfully using a syringe and a hypodermic needle. It has to be done in very small amounts. Over time, the 2 solutions will mix homogeneously and form crystals. Very few solutions exist that are compatible for doing this procedure. Although other procedures for growing crystals do exist, the slow evaporation process was best for the purposes of our alum crystal lab. Stay tuned for a follow-up on my crystals.